Okay, so most often, and it will be like uh, maybe 1% or at least 2% or at least 5%. You have to build the data set very cautiously. You have to always be alert, right? So that is where the SAS programmer's role is very crucial because that is the second piece. And secondary, I mean, whatever you are giving the report, that is going to be the final one. So it becomes, cumbersome sometimes, or it becomes messy, right? You have to, that is why, you have to find out the duplicates. You have to remove the duplicate if you are, finding it, or if you are duplicate, again, you have to report it and then it has to get deleted or it has to be considered for some other purposes. Similar kind of a thing if you are just going for social media platforms, data sets, informations, it is all unorganized, right? There is no system for managing all those things. And if you are just dealing with if you are entering all those data into decision tree where you are getting the decision making point, right? Okay, this is the sentiment analysis data, this is the feedback data, this is the recommendation data, how you are segregating, right? So each and every block, every tree has its own node, and each and every node it is getting connected with the root like this, right? So each root, and we have already discussed about this, but where the classification comes into place, where the entropy is coming into place, right? So wherever, I mean, whatever the place you are getting, with each split, the data becomes more homogeneous, which will decrease the entropy. However, some data in some nodes will not be homogeneous in nature, where the entropy value will not be small. So the higher the entropy, the harder it is to draw any conclusion. Okay, that means if the entropy value it is getting higher, that is, you can't come to a decision within this node. That is why you are just splitting into two. Okay. If the decision has been taken over here, that means the entropy value is getting smaller or very smaller. If it is getting higher, then again you have to go to the next terminals, next node. So if it is keep on going and we never come to a conclusion on the entropy value, then you have to go to the next algorithm that is called random forest. So please, keep in mind, as already told you in regression itself, whenever you are not able to, do or take a decisions, it is taking too much of decision nodes, or the terminals, I mean, nodes are getting expanded, then that is not fit for decision tree. That is going to be another kind of algorithm called random forest. Okay. So whenever you are just, analyzing decision tree, please keep in mind random forest. Okay, if at all any chance, you have to keep that data set into you have to train the data into random forest. Okay, so it won't, most probably, you can't say that, okay, this will be done within decision tree. No, you don't have that kind of a leverage, or you don't have any definitive path. It is going to be an infinity path. Then you don't have a control on it. That is what, because we are dealing with a lot of um, unorganized data. There is no systematic approach on any kind of data sets. Okay, right. So the higher the entropy, the harder it is to draw any conclusion. When the tree finally reaches the terminal or leaf node, the maximum purity is added. Okay, the maximum purity again, the at the time of the regression model, maximum 3 or 4. That is the nodes, the tree nodes, the limitations. If it is going beyond that tree is not, I mean, it is not going to be under decision tree. So that is where the purity is coming from. Okay, if the entropy value is very less, then purity is high. The entropy value is high, then it is a cumbersome or it is a very messy data. You can't filter out, and the decision points you can't come out as soon as You are just taking, reading the data, then you have to go to the next step. So how they are calculating the entropy. Okay, so this is the formula, right? And again, don't worry about the formula, just for your information, right? How the sigma value is being calculated for each and every iteration, right? And this calculation is based on your library. Okay, so this is what okay, where the train test and everything is there, everything is added, right? And printing the value of each and everything. Feature scaling has been done, and now you are going to enter into the model training. Yes. So scikit-learn, sklearn.tree. From this tree, you are importing decision tree classifier. Please, take a note of it. It is a decision tree classifier. It is not a regressor. Decision tree classifier. In this, if you are entering entropy, all these things has been considered by default. Okay, that is why it is getting printed over here. Okay, so if you are just, we need to discuss all these things: the alpha value, the weight, right? Because criterion we have already entered entropy. If it is entropy, it is automatically calculate this calculation. Okay, each and every iteration. So if we have a data set of 10 observations belonging to two classes S and no, if 6 observations belong to the class yes and 4 observations belong to the class no, then entropy can be written as follows. Okay. Just just for the understanding purpose of this math, math, just to follow this rule. Otherwise, just simply when if you don't want to confuse, just leave it. Otherwise, if you focus, please focus on this. Anyway, your entropy, that library will be taken care. Okay. And to calculate this, if you just do this, you are getting the approximate value of 0.971. That is within the range 0 and 1. 97.1 within this range. Then how do you classify this? How do you define this entropy? If all the 10 observations belong to one class, then entropy will be equal to 0, which implies the node is a pure node. Okay. If both classes yes and no have an equal number of observations, then entropy will be equal to 1. Okay, so you can just go to this formula. Okay. If it is yes and no classification, then this is how the purity of the information, the purity of the data set, the purity of the entropy will be, the the disorder, the measure of disorder, or the measure of the purity, or the measure of impurity, whatever it is, whatever the term you are giving, you are just taking the calculation, how you are going to measure. Based on that, you can get the entropy value. Based on that, information gain will be calculated. What is that information gain? It measures the expected reduction in entropy. Okay. Wherever you are talking about the entropy, the information gain is also in that entropy formula. That means it is wherever you are just reducing some kind of the impurity level in the data or messy data or the informations, whatever you are having right now, that is called as you are gaining some value. You are gaining some more purity. So entropy measures impurity in the data, and information gain measures the reduction in that impurity in the data. Okay. So we calculated the entropy. Within this entropy, we are trying to reduce this entropy value. That's called as information gain. So that is our ultimate aim in almost all the algorithms. If you see the simple linear regression, we are trying to reduce the MSE, That is the mean squared error value. Wherever you are finding out the less and less value of the error, then that is going to be your right fit line. The similar way, wherever you are going in these kind of models, whatever the models you are taking in, maybe the terminology might be different, but the process and context is very, very same. We are trying to reduce the error rate and increase the um, accuracy. Okay, right. So based on this, the feature which has minimum impurity will be considered as the root node. Otherwise, it will just leave as a blank. So information gain is used to divide which feature to split on at each step in building the tree. So just to see this observations. This has 10 observations, the color and the outcome. Okay. So as the okay, so we'll just see this example. Information gain is used to see the creation of subnodes increases the homogeneity, that is decreases the entropy of these nodes. The more the child node is homogeneous, the more the variance will be decreased after each split. Thus, information gain is the variance reduction and can calculate by how much the variance decreases after each split. So information gain of a parent node can be calculated as the entropy of the parent node subtracted entropy of the weighted average of the child. Maybe they're just you are very much interested in just calculating this. We are asking, uh, please explain in detail with simple examples. So entropy, we have an idea. Yeah. So parent node entropy, right? And child node entropy. Just see the example, the classic example which they have given. Okay, let's see. This is what I want to show you. So information gain is the difference between the entropy of the parent node and the weighted entropy of the child nodes. Okay, the information is gain equal to entropy of parent node minus weighted average of child node entropy. Okay. So we can just go, maybe I will copy this and just share it over here. And parent node entropy 97.0, child node weighted entropy 71%. Information gain is 0.26. This information gain tells us how much better our split is in reducing the uncertainty. If you are facing any kind of the weather forecasting uncertainty or the price, okay, so iPhone 16 Max Pro, how much could be the price? How to predict the before the introduction? Maybe in September, every September they are just giving, right? They are announcing their prices of the new iPhone. So I mean, there are so many channels. There are so many influencers. They are analyzing what kind of a prices they can set. So all those analysis will be based on this kind of a decision. They are just predicting some kind of an uncertainty based on the available data so far, right from 2008 to until 2024, right? Because an iPhone 3 model has been released in the year of 2008, and from there onwards, how the price has been set by the company. The higher the information gain, the better the split. Okay. So in a decision tree, the attribute with the highest information gain is selected for the next split of the data set. Okay. So we have to, I mean, they have given the examples and they have done the similar kind of things. So you have to go with the real time example. I will, can you give me real time example to understand better? Real time use case. So you're building a decision tree to classify whether an email is spam or not spam. Okay. So this is one of the classic examples. So contains offer in the subject, contains a link in the body, email from a known sender. So the parent node entropy, initially you have a data set of 100 emails, 60 emails are spam, 40 emails are not spam. Okay. Just consider this is really happening and we are seeing day-to-day life. So the entropy of the parent node before splitting the data is calculated as per the formula. Okay, 60 by 100 log 2 and 60 by 100 plus 40 by 100 and 40 by 100. Okay. So based on the logarithmic value, they have given a 97.1 is the entropy. This entropy indicates that there is a certain level of uncertainty in classifying an email as spam or not at this stage. It is very, very difficult because 97.1% of accuracy says that, okay, so all the emails are okay, spam. Or maybe the chance all the emails are not spam, right? Second one, the choose the future to split. I wanted to split I wanted to break down this, okay, to go into the spam or keep it in my inbox. So you decide to split the data based on whether the email contains the word offer in the subject. Okay. So emails with offer in the subject, 70 emails, out of which 50 are spam and 20 are not spam. Okay. So emails without offer in the subject, 30 emails, out of which 10 are spam and 20 are not spam. Again, the other, the child node entropy. For emails with offer in the subject, 50 and 50 spam and 20 not spam. So 50 by 70, 50 by 70 plus 20 by 70 and 20 by 70, and how the log value which differs, and it is equal to 86.3 percentage. Okay. Now the for emails without offer in the subject line, 10 spam and 20 not spam, the same thing. Okay. Weighted average of all the child node entropies. This one and two. What is the weighted? I mean, it is just a mere mean value. Okay. 87.9. Calculate now. You have to calculate 97.1 minus 87.9. This is almost 0.092. This means that by splitting the data based on whether the subject contains the word offer, the uncertainty has decreased by 0.092. Okay. Now, what is your information on this? So this is the real, uh, uh, based on the definitions, based on a couple of examples we have seen. How do you define? Now it is we have calculated the entropy, we have calculated the information gain, and based on this information gain, what is your assumption? What is your not assumption? What is your thought process? So based on this information gain, what is your decision? Because the uncertainty has decreased by 0.092. That means it has been, the the value of entropy value has been decreased, or the gain of this information, it is additionally it has been added by 0.09, almost 9.2. Okay, that is what it infers. So 9.2% has been, additionally you have, maybe you have to take from the positive side, And how are you going to, I mean, this is what my question is. How are you going to, you are going to take a decision whether it is going to be spam or not spam?
Here, since the uncertainty decreased, like
Hmm,
the entropy is, what is that, increased.
hmm, hmm,
The purity of maybe the what
hmm.
is that, a
It
data
is
set
getting
might be
reduced,
increased, in getting
increased.
purity
Hmm,
might be increased.
hmm, hmm.
So what we are trying to say, like uh, so out of 10 spam and 20 not spam, the
Hmm.
not spam getting that, what is that value what we are projecting, that might get increased.
Okay. So, okay, you are just, oh, fine. So it almost, so in this case, you used information gain to determine whether splitting the emails based on the word offer improves the classification of spam and not spam. Since the information gain is positive, it shows that this feature reduces the uncertainty and helps classify emails better. Still, we are not coming to the point which side it has to go based on the huge number of, I mean, the volume of data and also the volume of the reduction in errors and reduction in the purity, right? I mean, the impurity. So now let's say you compare this to another feature, like whether the email contains a link. If the information gain for the feature was higher, you would choose to split based on that feature instead, because it provides a greater reduction in uncertainty and more accurately classifies the emails. Right? I hope now you see, based on, I mean, if you are just classifying and calculating the entropy value, within that entropy value, you have, once you found out the entropy, and if you are just following the information gain, based on the information gain only, the entropy value is getting decided. So decision point always based on the entropy, where you are trying to reduce the impurity of the information, whatever the information, whatever the data you might be dealing with, right? So 0.092 value of the information, the purity side is just getting added. Say for instance, it is just 97 point. I mean, the entropy. What is the formula? The entropy minus the weighted average of uh, the child node, right? So we can just I will show you the, yeah. Okay. If the decision point, it's getting additionally something, some more points to make a decision at this level itself, the tree just stops over here. It doesn't go beyond this level. That is the point of the getting the information gain points. Okay. So entropy and information gain will be decided over here itself. It is getting more positive side. If it is more on a negative side, then it is going beyond to the next level. That is what it is saying. Because they are not showing like a tree kind of a structure, and this is what the information we have to come to the conclusions, right? So the next thing, what is the other thing? The summary of use case: parent node, all emails with uncertainty on whether they are spam or not. Split based on whether the subject contains offer. Child nodes, two groups of emails, one group with offer in the subject and one without. The information gain 0.092, indicating a small but significant improvement in classification after the split. Okay, these four steps are happening. If these four steps are happening, then based on the information gain, it is just stops in this third child node itself. It won't beyond go to the second child node, the third child node, the fourth child node. It won't go beyond this point. If this goes beyond this point, the information gain will be more. If this information gain is more value, you are getting more and more value, then your tree structure is getting low. Then obviously it has to go to the next algorithm called random forest. This is what you have to gain when you are getting the information. The similar, maybe, let's look at this example. As per the above example, belong to yes or no, where 6 observations belong to yes and 4 observations plus to no. Okay. Red color has 3 yes outcome and 3 no outcome, whereas yellow has 3 yes outcome and 1 no outcome. Okay. So this is the classifications and weighted average information gain should be 0.047. For a data set having many features, the information gain of each feature is calculated. The feature having maximum information gain will be the most important feature, which will be the root node for the decision tree. So if the maximum information gain is there, which is for this is the root node. For this is the root node, and this is how we have to uh, connect the dots. So it is not only one root node for any classification. This is for this is the root node. For this is the root node. I mean that is how we have to consider in this example. If it is all these things are root node, then you will get a confusion. I mean confusion. So that is also one point I had to mention. Okay. So what is the other point? Okay. So the feature having maximum information gain will be the most important feature, which will be the root node for the decision tree. Okay. There is one more methodology beyond this point that is called as Gini index. Okay. What is Gini index? Gini index can also be used for feature selection. The tree chooses the feature that minimizes the Gini impurity index. The higher value of the Gini index indicates the impurity is higher. Both Gini index and Gini impurity are used interchangeably. So most often, if it is based on the data set you are going to consider, okay, so mostly on deep learning models and very specific models, we are using Gini index. Otherwise, we are using only the entropy models, because entropy means entropy and also the information gain. They are just both together. But Gini index and Gini impurity both are coming. I mean, both are this. It's like the entropy and this information gain. Okay. So Gini index and Gini impurity are used interchangeably. The Gini index or Gini impurity favors large partitions and it is very simple to implement. It performs only binary split for categorical variables. It gives the results in terms of success or failure. Okay. Wherever you are uh, uh, having the calculations, having the type of the categorical data sets, you will be using the Gini index. But still, um, even if it is a continuous variable, if it is a continuous features, most often you will be using the information gain and the other thing, right? But the thing is, in Gini index, most often it might look very simple, but the purity of or accuracy value, it is I will show you the example. Okay. What would be the best approach?
So, Srinivas,
Ah,
like Guinea in will be the part of decision tree classification, or it is going to be
yes.
a separate approach?
No. It is, see, um, the optimization techniques and these kind of techniques are not part of any kind of a, algorithm. You will be using based on the requirement. Say, for instance, uh, if you, I mean, without optimization, no models are there. Okay. So wherever the optimization taking into place, you can also consider the gradient descent optimization. I think we have seen 4 optimization techniques as of now. It is not based on only on that particular models. We can use it for any kind of a model, even basic machine learning, even basic deep learning models. So it is not only with respect to that particular model. It is coming along with decision tree, right? So you can use Gini index for any other models too, and also you can use this information gain and this the entropy model. You can use it, but you have to use based on the use cases. You can't apply all these things for each and every way. Okay. Even in the entropy, you can replace with any other, maybe RBF. We have seen the SVM, right? For SVM, RBS is making sense, but don't assume that RBF is only accustomed to, or it is only for only used for SVM. No. So those kind of a feature selections can be utilized anywhere, because these are all the mathematical conditions you will be able to use across the models. But whatever we have seen so far, the standard process only that has been proven technique, and that has we have some kind of a proven track record. If you use these kind of a selection processes, we are getting some results. Okay, that is how we have to say, or we have to come into the conclusion. But you can't restrict that. Is this only for decision? This is only for SVM? No, you can't restrict those kind of things into one particular model. That is also one of the things, the confusion, or not a confusion, maybe challenges in your real life work environment. You have to decide based on your experience. Okay, so how do you choose in Adam model which the procedure you have to use? You will be using based on your experience, right? Because sometimes you will be using ProgGLM. Other than ProgGLM, what kind of models you will be using, right? It is up to you. Maybe SAP will which guide you some of the informations, but beyond that, you also can make a decision. SAP will guide you some of the, will throw some lights, but at the end of the day, it is the programmers, the recommendation too will be taken into consideration. A similar way, this is also okay. So the Gini index can also be used, right? This is also just consider this. The tree chooses the feature that minimizes the Gini impurity. I mean, that's what we are success or failure. The Gini index can be calculated from the below mathematical formula, where C is the number of classes and pi is the probability associated with the ith class or ith iteration. Let me first. Okay, what would be the best approach for a given condition for a decision tree? You have to mention this without the classification. Model. What would be the best approach for a given condition for decision tree classification model? Which approach will be appropriate? Is it index or entropy? How could we solve? I think this is your question, and right. Obviously, this might be okay. So when building a decision tree classification model, we typically have two main options for choosing the best splits: Gini index or entropy. Okay, so both are commonly used in decision tree algorithms like classification regression trees and ID3 C 4.5 respectively. What is this ID? I'm just seeing it for the first time. Still working. This. Straight away we'll just do the decision trees. Just we'll do some reverse engineering. Gini index fast, entropy slower due to log calculations, sensitivity to class imbalance, less sensitivity, more sensitivity. Tree structure often leads to similar results. Okay, now you know why you are getting the similar results in your repeated. That's what we just discussed few minutes back. So you are not getting the creative ideas, creative approach from the LLMs. This is because maybe they would have used Gini index, right? This often leads to similar results, and you won't get anything. And this is also that is also one of the the major issues, and there is no big difference between both the models. Interpretability, right? I mean, interpretability is simple to explain, aligned with information theory. Yes, information gain, and this is again it is often regression and classification decision trees. Okay, um, let's see one of the informations. Okay. Impurity, right? Entropy, it is uncertainty or disorder in a node. Right? How to decide between the performance and speed, resulting key structure, interpretability, how the both methods result in trees that are interpretable. The information gain using entropy is more theoretically aligned with the concept of uncertainty in the information theory. Okay. Some practitioners prefer entropy when they want to explain the model's decisions more deeply in terms of the detection of uncertainty. See, again, it is your decision, and you should have a proper reasons why you are using. There is no question of why you are using, and it is mandate that you should use. No, there is nothing, and it is based on the researchers, and it is based on the data scientist responsibility, and they should have a proper reason why they are using information gain, or entropy, and why they are using Gini index or Gini, the other values. Okay, so how it is, you have a large data set, millions of instances, and performance or speed is a key concern. You're using the Gini index in a cart decision tree would be more efficient because it is computationally simpler. See, going forward, you can see this word mandatorily, the computational power. For each and every algorithm, you have this kind of information. The computational power, which often leads to your GPU, your graphics card in your laptop or a PC or anywhere. Okay, based on that only, you have to do the algorithm, or you have to run the algorithm. Without that, please don't download anything into your local system. Right, that is why everybody is they're using cloud space. Well, cloud space is also you have to pay for more cost, but still we have to take based on the conditions, based on the problem statement and everything. So we will come to that point whenever you are just using your problem statement as a product. Okay, the small imbalance data set. If we have a small data set with a class imbalance, 90% of instances are class A and 10% are class B. In this case, using entropy might be a better option because it is more sensitive to imbalances, and the slight computational overhead will not be an issue. So based on the problem statement, but based on the data sets or records, you can choose either entropy model or Gini index model. That is the general recommendations. You have a large data set, speed is priority. Your